at the very bottom of your, the silly story looking notes, right? With the dating analogy things, right? So at the very bottom, we wrote combustion. What are going to be my products every single time for combustion, no matter what? Exactly. CO2 and H2O. Good. All right. Energy is what during an endothermic reaction? So this is the opposite. This is where energy enters. So is energy released or absorbed? This one is it's absorbed. Good. Now you look at that and you're like, okay, if it enters the reaction, then why isn't it getting hotter? It's because it's sucking it from your hand, so your hand feels colder. Okay? So temperature according to you will go down. Here, temperature according to you went up because it was released into your hand. Okay, the next one. What does the law of conservation of mass say? Mass cannot be created nor destroyed. We're going to answer that question about 2 more times, just so you know. It's kind of the same thing, it's just worded differently. All right, what is a balanced chemical equation? What has to be equal on both sides, besides the mass, right? Because you guys didn't know that beforehand, before today, right? What have you been doing to balance your chemical equations? What has to be equal? The number of what? Of the element. Yeah. That's good. All right, so the number of atoms. Number of atoms for each element, right? So if I have 3 hydrogens on one side, I have to have 3 hydrogens on the other side. Okay? All right, number 8. What information can you determine from a chemical equation? Okay? So shout some words out. What have we gotten to see with the chemical equation? What information can we see in this chemical equation? What did we have? You had subscripts, so we had subscripts. So really that was like the compounds, right? So all of the compounds. So we know that we can get our reactants and products, right? So ingredients and what you're making. We can get states of matter. So I'm going to put SOM, states of matter. We can get, when we balance, I keep asking you about a mole ratio. And I would actually say that's probably it. You know who your reactants are, you know who your products are, so what elements are involved, what compounds are involved. States of matter, mole ratio. That's pretty much it. All right. What? Oh, that's yes. Okay. What do we use to balance chemical equations? We don't use subscripts. We use, starts with a C. Ends with an coefficient. Coefficient. Okay. So we use coefficients, not subscripts. The big number in the front, not the little numbers that sink down. All right. In a chemical reaction, the total mass of reactants must be equal to, you guys got this. Total mass of the reactants has to be equal to who? The products. Total mass of your products. That's what we were just now doing, right? So, for your guys' example, can you, because I don't think I actually asked you, here, give yourself the little example right here. Just go ahead and say hydrogen plus oxygen makes H2O. And we'll just go ahead and give ourselves the example that if I have 8 grams of hydrogen and 4 grams of oxygen, then I'm going to make how much water? You guys, how much water am I making? 12 grams. Good.